have to do it before you can do the retake. All right, so this is worksheet 9. You don't have this question. 9.
I have no idea what to do.
I started the recording, and it's worksheet. We're going to do 9B in just a second. It looks like this, yes? 9B?
I bet it does.
Okay. We're going to practice our SAT question for today, though. This is what's a level 5 question. It is, I think they call it like Foundations of Higher Math, or it has some funny name. The highest, it's the highest, hardest kind, yes.
Awesome.
All right, it says in an XY plane, which just means it's a coordinate plane. There's a line, okay? Line K has this equation. Line N has this equation. They intersect at this point. When you have two lines that intersect, what do you know about that point?
It's on both lines.
It works in both equations. Does that make sense? Okay. So what could we do with this point that might help us find something? We want B. We could set them equal, and then we'd plug in A. I think we'd still have an A and a B. I don't think that's going to help us. Yeah, if we plug it in this first one, we can find the A, right? Okay, so what are we going to put in for the Y? 2/3. 2/9. X, we're going to put in A plus 5. Okay, use your calculator. 2/3 minus 5, and then multiply by the reciprocal or divide by 2/9 and give me an exact answer. So 2 divided by 3 minus 5 is negative 13/3. And we got to multiply by the reciprocal of that. Wow, I got negative 19.5, yes? Which is negative 39/2.
Yep.
You can use 19.5, doesn't matter, it's exact. Okay, now what? We're trying to find B. Yes, we're going to plug A. We now know this is negative 39/2, and 2/3 is now this point where they intersect. So if we plug it into this one, we'll find B. What are we going to put in for Y? 2/3 equals 1/4 times negative 39/2 plus B. I'm not finding an easier way to do this one, or a faster way. We'd have to add this, right?
Oh, that's what I do.
We got 133/24, which is what we got this morning when we did this question. Okay,
Must be right.
that was a disgusting answer. There are actually some, what's wrong? Did you find an easier way? This is a SAT prep question, just like a bell ringer. Yeah, it's not, yes, it's not on there. All right, there's a part of the SAT, guys, where you would have to actually bubble this. 133, you'd bubble the fraction bar, 2/4, so you'd go down here, 1, 3, 3, fraction bar, 2, 4, whatever, and you have to fill in bubbles for all those little things. Isn't that lovely?
That sounds like pencil round.
Parts of it are multiple choice, but okay, the SAT is two separate math parts. One is all with a calculator, and it's like, I'm making this up, 25 multiple choice and 5 free response like we just did. The other part is no calculator, and it's like 15 multiple choice and 5 free response or whatever. Okay? I don't know the numbers. I can look it up. But all right, Newton's law of cooling. Newton's law of cooling refers to taking a cake out of the oven and setting it on the counter. Okay? It cools quickly and then it slows down. It is chemistry, and we're talking about it here because you need logs to solve it. Okay. Newton's law of cooling will help us figure out how long we can wait until we can frost the cake and eat it. Does that sound like a good plan? Okay.
Only if we're actually eating cake.
All right. Newton's law of cooling does ignore, okay, both of these formulas assume that the surrounding medium temperature, so they call this surrounding medium, means the air in the room you're in, or if you're talking about throwing something, a hot hard-boiled egg into a big sink full of cold water, okay? What we're doing, Newton's law of cooling assumes that the room temperature or the temperature of the water in the sink remains constant. It ignores the fact that it could affect, okay? In other words, if I took a really little cup of cold water and I throw a hard-boiled egg in there, the whole cup of water would heat up, yes? That's because it's a very small container. If I took a 10-gallon aquarium with cold water in and I threw one hard-boiled egg in that was right out of the boiling water, it wouldn't change the temperature of the aquarium very much, right? Might a little bit, yes. The same with taking your cake out of the oven. If you take the cake out of the oven, it doesn't warm the whole room up. Probably the oven opening up warms the room up more than the cake sitting there, right? Okay. Yes, so it ignores that. Just like there's all kinds of formulas in physics that ignore friction or something, right? We're just, yes, ignores air resistance, whatever, all those things. All right, this formula is on your pink sheet. The one on your pink sheet uses M here instead of S. They call it the surrounding or the surrounding medium. In other words, whether it's air or water or whatever it is, the surroundings, okay? So I think on the test I used S because I did write the formula right next to the question. So you really didn't even need it on your pink sheet, but it's on there. Here we go. A cup of coffee has cooled from 92 degrees to 50 degrees. After 12 minutes of sitting in a room at 22, the room temperature is 22. How long until it cools to 30? We cannot solve this part yet. We have to wait. Because first of all, using the information they gave us, we have to find the cooling constant for this cup of coffee. So, where's the final temperature so far? No, that's what we want the final temperature to be in the end. But first, we're going to ignore that and say so far it's cooled to 50. What was the original temperature? Okay, how long did it take? That's the little t that's up in the exponent. Okay. In a room where the temperature was 22, which is TS or TM, depending which formula you're looking at, okay? I just want you to know it's the same thing. All right. So the formula says we take the final temperature and we subtract the room temperature. We set that equal to the original temperature minus the room temperature. Lots of difference in. Change in temperature, change in temperature. Okay? And then we have e to the negative k, which is what we're trying to find, times, what's our time? Okay. I'm going to do a little rewriting here. 50 minus 22 is 28. Whoa, that's a weird 8. Equals 92 minus 22 is 70. E to the, now, can I write this as negative 12k? Is everybody okay if I just move that 12 out in front like we usually do when we have a variable? First thing, We solved lots of these yesterday. What do? Divide. 28 over 70. I'm just going to leave it. You can type it in. I think it comes out nice even. 0.4 maybe. Now, why did I write that clear over there? What's the next step? We need to take the log of both sides, yes? So I left myself room to write that. Tricky of me, I know. All right, what happens next? Yeah, this moves down here, and ln of e will just be 1. So we're going to type ln of 28 over 70. And what do we have to do then? Divide by negative 12. K is going to be positive. So 0.0764. 3, 4. Okay. Guys, please type this. I have a lot of you got things wrong on the quiz that I'm thinking you just weren't following along in class, and so you're not sure how to type stuff in. Everybody getting that? 0.0764. Anybody not getting it? 5th period, I had some people who were trying to do things in different orders, and then they were coming out with different answers. Sometimes there's something you could do. You could obviously do ln of 0.4, right? Everybody good? All right. If that was fun, we get to redo the whole question to find how much longer. The only thing that's going to change now, we're on part 2 here, is what's our new final temperature? 30 degrees. And we have now the constant, we're trying to find time. Yes, exactly. So let me start it looking at the formula up there. The new final is 30. Okay? Everything else stays the same except we're going to put in our new K. So negative K is negative 0.0764, and we're trying to find T. I love that I can hear some of you typing away. What do we do first? Divide by 70. Did you not use the negative on the K? I'm going to take the log of both sides, and then I'm going to have the natural log of 8 over 70 equals negative 0.0764t. So I'm going to type it in and divide it by that decimal. Don't forget the negative. Try again. I think you left a decimal out somewhere, or moved as 0.076. Did you get that part? With the 0 in? Did you do 8 divided by 70? Because I think it's 20. How much is it? 28 minutes? This cup of coffee must be for my daughter, who has a very tender tongue. I swear she can't drink or eat anything till it's like room temperature. What's the point in drinking coffee if it's room temperature? Still has caffeine. I guess that would be. I still didn't get that. Oh, I transposed 2 numbers. Darn it. Did you get it, Basma? Yes, 28.39 or 28.4 minutes. Since we're talking about time now, around 28 minutes would be fine with me. That's a long time to leave your coffee cooling. How long does yours usually take to cool? Not that long? It takes that. You know what makes a difference for me? If I don't take the lid off, then it takes forever, yeah. You burn your tongue every time? Yeah. All right. This is a better question. I like this question. We're going to take the cake out and wait for it to cool to frost it. Okay? So, can you work on this one, guys? What's the final temperature? We don't use this until the end. We've got to wait on that number. What are we going to start with? It cools to 120 when it was originally 350 is the original temperature of the oven. That's what the cake was when it came out. Originally, to find the constant, we're using 20 minutes, where the room, the surroundings, or the medium are 65 degrees. Okay, I'm letting you work. Thumbs up, thumbs down. Anybody get 0.0823? Anybody not getting 0.0823 that can come help? Did you not put the negative in when you divided? Divide by negative 20? That's usually what happens. Just remember for the test, K is going to be positive and your time is going to be positive at the end. If you get the opposite, you probably just forgot a negative somewhere. I do have 822, but the next one is a 5. But it would probably not be if you rounded somewhere. So if you put 0.822, I'd be thrilled. It's not going to be wrong, okay? Because it depends. If you divided the 55 by 285 earlier in the problem, I'd get a different answer. We're all good. All right, keep going. We got to start over. Now what's our final temperature? Yes, you're absolutely right.
I'd be like, alright, it's been like half an hour. I mean, not like I'm going to do this calculation to figure out how long it's going to take my cake. I should. When I make pies for Thanksgiving, I'll do this. I will. Will that give me extra credit?
Am I the only one who, like, in the winter sticks the cake out on the back porch so that it cools faster?
Oh, I put it in the freezer all the time.
I never have room in the freezer.
We just got a new fridge.
Or we just eat it while it's too hot, right?
Yeah, pretty much.
And the frosting just kind of melts.
That's what I do. I'm pretty sure my taste buds can't feel.
Yeah, who actually lets brownies cool? What's the point?
What is the point of letting brownies cool? I don't think I've ever let anything cool before, even before icing it. I just do it. But making it
Okay. ln 25 divided by 285 and then divided by negative 0.0823. 29.6 or something. 29 point something. Yeah, around 30 minutes. We're good? Okay. One more thing, guys. And then we'll do some of the homework together unless you have homework questions. Sound like a plan? On your sheet is this formula. N equals N sub 0 and I wrote a big R on your sheet, T over H. Pink sheets, that's one we wrote on the pink sheet, remember? Handwritten on the pink sheets. Okay, this is a half-life question, so guess what magical number they put in here? 1/2. What does n sub 0 stand for? The beginning initial amount. In this question, we're starting with a 120 milligram sample. All right. T is time. H is, be careful, this is also time, but H is the length of the half-life, okay? Length of the half-life. How long is the half-life for this question? The half-life of radium-226. Guys, you never use that number 226 in a problem. It's the name of the substance, okay? 1600 is the half-life, so that's the H. Okay, what do we get to do for this first part? How much will remain after 4,000 years means T is 4,000, and we just get to do some typing, right? Everybody type this one in because you need some crazy parentheses if you have an older calculator, because it's to the power of, and you need parentheses around that. Please make sure you get this answer. Otherwise, I need to talk to you about what's going on with your parentheses situation. $21.21. 21.2 is fine, I don't care. No, you did not get that? You need me to come look? Anybody else? Did you figure it out one way or not? Thank you for helping. All right. This is what this is all about, guys, is working backwards to solve when will there be 10 milligrams remaining. This is about the equation solving, okay? So we're taking the same equation we had right here and wanting to know when we'll get down to 10. Yes, good job. Sarah said 10 equals. And then we're going to do this. What are we going to do first? Okay. 10 over 120, which reduces, but I'm just going to leave it alone for a minute. Then what are we going to do? Why do we do a log? Because our unknown is in the exponent. Okay, you could do log or ln, doesn't matter. Once we do the log, this comes out in front. This is not one that everything cancels like we just did, right? You end up with log of 10 over 120 or 112 equals T over 1600 times the log of 1/2. You could do this in a whole bunch of order. What do you want to do first? Yeah, I divide by the log first usually. So I do the log of 10 over 120 divided by the log of 1/2. Can I just skip a step or anything? Yeah, you could do times 1600 and then divide, or you could take this divided by 1600. But you can't condense those two logs, right? Okay. Subtracting two logs becomes a single division, but dividing two logs doesn't become anything. Okay, now what? It is a big number.
Yeah, I thought at first it was milligrams. but that's not right.
No, it's years. 10 divided by, log of 10 divided by 120, close parenthesis, divided by log of 1/2. Okay, I got 3.58, and then I have to do what to get rid of this 1600? Times 1600. Yes, I got 5,000 something. Good job. Five, 7, 3, 6 years. Good job. We okay? All right. There's a couple questions I would like to do with you on worksheet. One I want to do with you on 10A. Couple on 10B I want to talk about, and I might cross one off if you're really sweet and kind. And you're my favorite class, right? Shh, don't tell anyone else.
You know, she probably told that to every single one of her classes today. So, not feeling so special.
Yeah, not my 6th period, but they won't watch a pre-calc video, so it's okay. All right. This is Newton law of cooling on 10A, so we're going to skip that one. This is Newton's law of cooling where they give you the constant, so this is an easier question. Okay, you don't find the constant first. It also doesn't give a label. I assume it's hours. It's a dead body question. All right. This is what I want to talk about, logistic growth. We're going to talk more about this tomorrow because we're going to do some exponential regression and logarithmic. What we're going to do tomorrow is talk about, and you will need to recognize for the test, different kinds of growth. What would this be doing? Yeah, this is exponential growth. Nicely done. Okay. Remember when we were taking the test and things looked like this? What was that? That was the inverse of this, so it was logarithmic. I think there's an IA in there. Okay. You also need to know quadratic, cubic, right? We're good with those? Linear. Okay. The new one is this logistic that we're talking about today. Let me explain. It is when you have, for example, you got a lake out here. It doesn't have, you just built a new pond in your yard, okay? Great big, ginormous 20-acre pond. Wow. You throw 10 fish in it. What happens is those 10 fish eventually find each other and start making baby fish, right?
Yeah, and that's when you get your pond.
Okay, and they grow very slowly. But what happens when you get up to 200 and they're reproducing? Starts to grow more quickly. But what happens at some point because of the size of the pond? Yeah, it maxes out and maybe even it eventually dies off, but eventually it reaches kind of an equilibrium, right? Unless other things change, like you start throwing some, nasty stuff in there that kills them, that grows too much algae, whatever. Okay? So this idea that, I didn't draw this very well, but it grows kind of slowly, then it grows more quickly, and then it levels off for an environment or a habitat. Does that make sense to you? Okay. So this question is talking about bears. It says, we have introduced some bears into a wildlife area, and this is the growth function. It is a logistic function. Guys, as long as this number down here is 1, generally this is what it's going to approach the maximum population. But we'll check that out when we graph it, okay? We're going to put this in our calculator. And y equals. How many parentheses? 2 to 4 maybe? If you have the newer operating system, I think you might only need 2. 2 around the bottom, right? Mine uses more when it prints it up here at the top of the screen. I don't know if you can even see that. That's not what I wanted. All right, when I type it in, yep, I'm going to talk about the window here. But I put in 1 parenthesis around the whole bottom, and then if you don't have the calculator that does the little box up here to put your exponent in, you need another parenthesis so that both the negative 0.3 and the x are in the exponent. Morgan, you need me to write out what I'm talking about? You would do 300 divided by parenthesis 1 plus 19 e to the, and then you'd have a parenthesis negative 0.3 x, close both parentheses, okay? All right, window, what is our x representing? Time. I think I did 50 years. You can do 25. I'm not sure if you'll need to go further eventually. You want to go at least far enough that you see it start to level out, okay? What did we say we thought this was going to max out at? 300 because of that top number. You can do 300. I did 400 just to make sure that it was visible. If your graph is not doing this, then we need to talk. It's not doing that? My window? 0 to 50 and 0 to 400 I did. And I probably should change my scale, but I never bother to change my scale. I'm a bad person.
Me too, but not because I don't change my scale. I don't ever change my scale. I might meddle with like
all right.
Scale, you know, to make myself
yes.
Way less than I actually.
Did you put the negative in?
I'm so
We're just on an X.
I would like to think that
Was it
but
You can tell me what you had wrong.
yeah, your mom's really smart. I bet you it's probably a curse and a blessing. Blessing? You can eat whatever the heck you want. That's true. Not really. You're really skinny.
Everybody else good? Okay, so let's run through the answers. What does it ask? How many bears initially? How do we find the initial number of bears? Yep, put in 0. I have it graphed, so what could I do? Trace 0. And I write down 15 bears over here. 15. Then it asks 2 more questions just like that. Can you do those quick? Ten years, 30 years. You can round to the nearest. Oh, it did say 3 years over there. I totally skipped 3 years. At the end over here, it said 3 years. No, just round to the nearest is fine, or down. I don't care. I'm not that picky. Well, we didn't get to do a lot of applications because we never got that far, which is really stupid because that's, I know you guys don't really like word problems, but what are you going to have to do the rest of your life? Real applications, right? Unless you're a math teacher and then you can just do equations for the fun of it. Okay. When will the population be 50? We are not going to solve this by trying to work this disaster backwards.
We should, just for fun.
We are going to use our graphing calculator and put in the line at 50.
Let's do it for fun.
And then do what?
You intersect and you get a 4.45.
Intersection
I'm going to have fun with this thing.
4.45. For about 4.5 years.
I just switched it just
What will the maximum number approach? What did we decide there? 300. And we got pretty close. If you scroll out to like 50 years, it comes out to 99.998 or something. So we're going with 300 bears would be the maximum that this environment could support. All right. Yes? Oh, I'm sorry. We put in the line at y equals 50 because we wanted to know when it hit 50. So we put in y sub 2, and then we did an intersection. All right. Great question.
Wait, did I get the same answer? I solved it. I was right. What was the answer?
4.45.
Oh, I got that. We did it right.
Good job. All right. What? We just put in the time for x. So we just did trace 0, trace 3, trace 10. Okay? You could also look at the table, Morgan. All right, guys. Turn to 10b real fast because I'm going to do this question in 30 seconds or less and tell you you don't have to do it, okay? This is a little more complicated. Requires a lot more parentheses. If you put in 50 for the initial amount, it does something like this, okay? If you put in 1,500 for the initial amount, it looks more like this. If you put in 10,000 for the initial amount, it actually does this. Because this is not 1, when you put into this, I think it comes out like 6,000 is the maximum number of rabbits. So what happens if you put 50 rabbits out there, they reproduce until they reach 6,000. But on this one, if you put 10,000 out there, they die off until there's 6,000. Okay? All right. I just wanted you to see that a logistic can also go down if you introduce too many into the environment. But moving on, because I'm not going to make you do that question. Too much typing. pH. You've seen this formula before. Do you remember the video that we did the first day about the chlorine in your eyeballs? Remember the chlorine? No, he talked about what's the difference between 0.0000378 and 0.0000378. Remember that video? Okay. So he talked about this formula. The opposite of the log of the hydrogen ion concentration will give you the pH. So all you are doing on these, guys, these 4 questions is typing. And the homework? Yes, there's one in the book as well. Negative log base 10, or common log, of 5 times 10 to the negative third. I got 2.3 for the first pH. Okay, it says up here, pH between 0 less than 7 is an acid, and so on. Everybody okay with doing those? Okay, I want to do this question. This question asks us to go backwards. If the pH is 6.5 for milk, can we find the hydrogen ion concentration? What are we going to do? I'm going to just call that H. You have to do what? No. Not yet.
Well, you have to divide first. After
Divide by what?
-1.
Okay. You need to make this negative 6.5 and then do 10. So you end up with 10 to the negative 6.5. Okay, so your hydrogen ion concentration is this. Okay. One more question. Please, we're going to run out of time here. I need you to look at number 10. This is on 11A, number 10. We're using this formula again. But it's a little tricky. First of all, it says the half-life of carbon-14 is 5730. That's going to be the H. Does that seem okay? What is the rate? The R? No.
Oh, that's how much it
It is 1/2 again, 1/2 or 0.5. This, it says, a wooden artifact from an ancient tomb contains 65% that was present in living trees. In other words, that's what's left is 65%. What are you thinking, Kate? You could put over here 100, and you could put over here 65% is less. Does that make sense? Could we just do 0.65 and 1? Then we wouldn't even have to divide. So now when we take the log of both sides, we have the log of 0.65 equals, if I bring this disastrous exponent out in front, we have t over 5730 times the log of 1/2. So we got some kind of messy dividing to do. I usually divide the log first. You could do it in a different order. And then multiply by the 5730. I think it's old. Is it old, guys?
It's pretty old. You can say ancient.
3561, someone got?
Yep.
Okay, guys, number 11, you use 42%, but you still use the 5730 for the half-life, okay? Have a good night, guys. Remember,